All right, welcome back to my electrical channel. Once again, we thank God. Right, in this particular video, I would like us to see how series and parallel circuits, how the concept of it and the principles of it. Now, when two light bulbs or loads are connected in series, now this is how it is. Now we know that every load has a resistance. The resistance means that now that is what an engineer you have to note, and then be able to understand that each and every load carry a resistance. So for instance, if a load is connected and another load is also connected in series on a voltage, now the same amount of current, since it's series, the same amount of current will flow through, meaning that each and every load by the current will give you a portion of voltage, and the other one also will give you a portion of voltage. So meaning that the same amount of current will flow through the two light bulbs or the load, but when it comes to the voltage will be divided into two. So one side will have a current and one side will also have a current. So I'm going on the board, and then I will show you how a calculation is. At the end, I will play a video for you, and then you understand the concept of how, if loads are connected, let's use the light bulb, because the video I'm going to show to you will be a light bulb. So let me talk about light bulb. So I'll show you the series. So after you understand the series, I'll come up with the parallel circuit. In electricals, the whole thing is that understand the concept. When you are working, if a facility is given to you, a place is given to you, you must apply calculation. Most engineers fear calculation, but you must understand calculation so that you may not overload the circuit. So when you understand the concept that I'm going to teach you this particular time, it will help you. Then if you have series connection, it will help you. Right, so let's go and then go to the board and do our calculation. Right, so this is the calculation. Now you can see two light bulbs connected, which this light bulb offers 3 ohms resistance. So this is the pressure. This is the load resistance on this particular voltage. Now, this particular bulb, the resistance is not given. Now, let me explain a little bit per what I've said initially. Now, the resistance on this particular bulb plus this resistance will give you what we call total resistance. And that total resistance multiplied by these two has to give you a total voltage of 10 volts. Let's do it, then you understand. So now, since in series circuit, same amount of current, what it means is that this amount of current, which is 2 amps, is the same amount of current which will flow in this particular bulb. So that means, let me draw the line, you see. So it's the same 2 amps. The same 2 amps is also going to flow to this particular bulb. So that is what is going to happen. This 2 amp is going to rotate all over. It's the same that will rotate all over and will end at this particular point. So now we are going to look for the resistance for this particular bulb. And this is how we do. Now we have the total voltage of 10 volts. I hope we get it. Now the total voltage is 10 volts. So now let's look for the total amount of current. Now, total amount of current is what? So total amount of current is what? Is 2 amps. Is that not so? Now that we see the total amount of current, that means this amount of current, since it's the same amount of current that flows in this 3 amp, and it's the same amount of current that flowed in this unknown load, and we are looking for that load. Now, what we do is that we'll multiply these two. If current is the same that move in what? Two component or two lows, then you multiply to each of them. But since this one is not good, it's not given, this particular second one is not given. Let's multiply these two by this 3. So this 2 by this 3 will give us 6 volts. So we know voltage is equal to what? Current times resistance. So that is the formula. So 2 by 3 is going to give us 6 volts. So meaning that 6 volts is what is going to flow in this particular loads. Now, this is how we do to get the resistance here. So this 6 volts has to be subtracted. We have to subtract this 6 volts from this 10. So 10, this 10, which is the supply voltage, minus the voltage in what? This particular 3 ohm resistor. So minus what? 6 will give us 4. So we are going to have 4. So now this is what is going to happen. So this 4, which is the voltage now. So now we are going to have 4 volts here. So you see, now 6 plus 4. You see, this is what I told you initially. I'll play the video also for you. So meaning that the voltage will not be the same. The voltage here, because the resistors are not, or the resistance will not be the same. We are going to have 6 volts and 4 volts. Meaning the voltage across this 3 ohm resistor and the voltage across this unknown resistor will give us 10. So 6 plus 4 will give us what? 10 volts. Here is supposed to be volts. Now, what we are going to do is that now we need to find the resistance, which is the second resistor. We have to find the resistance. And this is what we do. We know in Ohm's law, resistance is equal to what? Voltage over what? I. And since the current is what? 2 amps, which is the same current that is flowing through, then we say voltage resistance equal to what? These 4 volts over these 2. Yes, so that will give us 2 ohms. So this is what we have. So when we add these 2 ohms plus these 3 ohms, it's going to give us what? 5. So 5 by 2 will give us 10 volts. I hope you understand. So let's go so that I'll play the video. And the video is going to help you to understand this concept. It is not difficult. Just follow the principles and then you'll see that the whole thing. So let me come in again. In series resistance, the same current, amount of current flow through. Right, so let's look at the video. Right, use one bulb, is going to use one bulb. He used one bulb and then 2 bulb as a concept to explain. So if one light is resting or is connected on this particular voltage, what is going to happen is that the light is going to grow. It's going to bright enough. But if it's connected if 2 loads or 2 light bulb is connected, what is going to happen is that since the voltage will be shared, you have to know that the light growing or the light brightness will minimize. So that is the concept or how the whole thing is. Understand it so that when you are doing an installation, apply calculation. An engineer, you must not fear calculation. You must constantly, whether you like it or not, you must constantly know calculation. And the calculation is going to help you. That is what is going to help you so that whatever you do is going to be genuine, is going to be perfect, and you are going to have a good result. Right, so that is how it is. All right, so now I believe you understand the concept of series resistance. When 2 loads are connected in series on a voltage, same amount of current will flow through the 2 resistors, the two loads, and also the amount will be divided into 2. One of the load will have a portion of voltage, and one of the load will also have a portion of the voltage. As an engineer, you have to continue learning both practical and calculation. Very, very important to help your career. Right. See you in the next video. Bye for now.